The next thing I want us to talk about is going to be developing something like an if-then statement. Since we talked at the beginning of this course a little bit about coming up with our scientific prowess, 2, 4, 8, coming up with a null hypothesis, students still struggle with how to do that. So one of the things that I like to make sure that I really kind of nail in on is an if-then statement that gives us the basis of our claim. Now, you all are going to be getting one of these very nice posters from Activate Learning, the Claim Evidence Reasoning, or the CER type of methodology when we're looking at devising a way to communicate anything that we've researched in science. So if we think about our SEP, obtain and communicate information, how better to teach a student to communicate information than using a method where it can actually be looked at as a way to develop both their own argument and also to be able to break down the scientific arguments of someone else. One of the things to do about this is beyond this, I'm not going to just sit here and read this to you. Unfortunately, I'm going to do that a little bit more in a moment. I am going to be including this lovely picture that I procured on the internet. I did not develop this, but it does make things very easy when giving students sentence starters, particularly as I'm not an English teacher. That gives me an opportunity to just make my life easier. Anything you can do to make your life easier, I recommend it, particularly when it comes to the classroom. So an example of this would be some sentences to help you frame, to have a student be able to write a claim, would be blank causes blank, or blank is the reason for blank. Blank and blank have many differences. Or if this, then that. Wait, we just talked about that. That's our hypothesis. Claim kind of fits along with that. That's what our claim is going to be. Now we're going to try to disprove our claim, but we still need to be able to back it up with evidence, which is kind of where the students kind of get squirrely. They say, wait, am I supposed to prove it or am I supposed to not prove it? Both, and that's the fun of it. So then evidence is going to be obviously what we would support our claim with. So based on this information, this is where I come up with the idea for the claim, even if I'm going to try to disprove this by coming up with new evidence, and then this will eventually be my reasoning for that. So the text states, okay, great, our textbooks are great, or maybe if you're using an online version of that, or according to this article, or in the activity that we did, or it was discovered that, like in the middle of actually doing an investigation, that investigative box that we started building earlier, that's kind of the way that I want us to kind of start looking at that. Evidence is going to be something that will be useful, of course, not only in your class, but all the other teachers will thank you for actually teaching the students what it means to come up with evidence. And so will all your Facebook friends. That's a joke. Reasoning. Nobody cares about your reasoning on Facebook, which is why I said that was a joke. The reasoning itself explains why the evidence is going to be supporting the claim. So this supports the claim because that's about as simple as I can get. So I'll just have some of these sentence starters that'll be in your file folder on Google Classroom that you'll be able to, Google Classroom, not in my classroom, just on the Google Drive. We're going to share that with you. All right. Next thing is going to be, this is really going to be more for outlining. That's the whole purpose of why I'm going into this, and that's going to lead us into using debate in the classroom, which might scare some people, and particularly students. You actually have to talk to people. Yes, it'll be very helpful for you in your life. So in my article that I'm going to show you, we need to be able to break that article down. So we're going to be using a technique called scalar. So I'll just write that up here. So scalar is going to be skim the article. That's going to be the first thing. So before I even begin doing any kind of reading of the article in depth, I want to make sure that I am scanning through the article to make sure that I'm seeing, okay, what am I looking for here? Oh, cool, there's a picture of a telescope or something. Okay, here's a picture of a graph. I don't know, that's probably important. They put it in there. Keywords, headings, anything along those lines is going to be very helpful for us. Next is I'm going to be creating an outline based on the article. So now I actually have to read it in depth enough to see what I'm going to be breaking down. I'm going to provide you all with an example article from 2018, Chill of Solar Minimum, very interesting article I'll be reading to you in a moment. And then an actual outlining tool. This is something that I developed. Feel free to use it, change it, modify it, it's fine. It's not copyrighted. I don't believe in intellectual property. Okay, so then we're going to come down to ask the thesis, a question of the article. So when you're developing your outline, you actually need to come up with what is the main point. What's the claim that this article is trying to make? Then we're going to list out all of those claims. So we've got the main claim, what is the thesis, what's the main idea, and then what claims are being made that are related to that thesis. And then E is evidence. We're going to be looking at the evidence and evaluating that evidence using the scientific method. And I don't know too many people who read scientific articles with the scientific method in mind. You might be one of those. I hope you are, because that says a lot of good about you. And then we'll actually do the responding to the article, and you may do this in a variety of different ways you can pull out of your teacher tool bag. So I'm going to read this to you, and I'm going to go through how I would outline this. I'm going to try to do this as quickly as possible for you. This is something that you would be able to do. We would have all been doing this in class. You would have partnered up with individuals, but again, this is as best as we can do right now. So the first thing that we have is the article name and author and the published date. So I'm going to look at this. I'm going to write out the chill of solar minimum. It was published on September 27th of 2018, and the author is Dr. Tony Phillips. All right, first whole line is done. Next up, what is the question raised by the article? Well, let's go back to the scalar model. I'm going to kind of model that. So let's kind of look through this. I'm just going to come to the other side of the table so that you can see this a little bit better, so you all can be able to look through this yourself. I understand that this may still be difficult for you to read. That'll be up to you. Okay, so we've got our title here. We've got a picture of a satellite. This is an interesting, we got this lovely picture here talking about the ways that different types of light wave radiation and heat work through the thermosphere. And then, hey, look, a graph. Students love those. But we can kind of go through that. And look, there's resources. So we know that at least this appears to be a legitimate scientific article. So now that we've kind of got a general idea, let's see if there's any headings on this. There will be a link on this so that you can actually check out the website it was published on. No direct headings. So let's see if we can come up with what the claim or the thesis is. So now I actually have to read the article. September 27, 2018, the sun is entering one of the deepest solar minima of the space age. Sunspots have been absent for most of 2018, and the sun's ultraviolet output has sharply dropped. New research shows that the Earth's upper atmosphere is responding. We see a cooling trend, says Martin Milnizak of NASA's Langley Research Center. High above Earth's surface, near the edge of space, our atmosphere is losing heat energy. If current trends continue, it could set a space-age record for cold. These results come from the SABRE instrument, now on board NASA's timed satellite. SABRE monitors infrared emissions from carbon dioxide and nitric oxide, two substances that play a key role in the energy balance of air that is 100 to 300,000 kilometers above the planet's surface. Measuring this infrared glow of the molecule, SABRE can assess the thermal state of the gas at the very top of the atmosphere, a layer that researchers call the thermosphere. All right, this should all sound very familiar for you, particularly if you're a 6th grade teacher. However, talking about solar minimum is something that more of an 8th grade standard. So you see, we're already trying to bridge that gap. And then once we actually look into how this would affect the ecosystem, now we're talking about 7th grade. One article, 3 different ways that it can be used, and we're going to try to outline this. Whatever articles that you end up using in your class, whether that's through News ELA, Newsella, however you want to say that, this is a beneficial tool. So I'm going to let you read the rest of the article by yourself, but we can go ahead and kind of get a general idea as to how we can come up with the things to put in the blanks on this outlining tool. So what is the question or answer that is raised by the article? So I would say that its first thing is kind of in the title. Solar minima would make us think that there is going to be a drop in thermosphere temperature. So what's the question? Or what's the answer? So the answer, this is going to be more of an answer, so I'm going to circle answer on the sheet, and I'll kind of bring this up to the camera so you can see in just a moment that this is going to be less sunspots equals lower thermosphere temps. So what's the claim? What's our first claim? All right, the first claim here is going to be that we see a cooling trend. I'm going to see cooling trend. Okay, what evidence is there to support this? Okay, this is coming from the SABRE instrument. So I'm going to put evidence is going to be coming from the SABRE instrument. And who's the citation? Well, that's going to be Martin Milnazak of NASA. All right, Martin. I'm just going to do M for simplicity here, and I'm going to say comma NASA. All right. Now, is there any additional evidence for this? Okay, so we would look at, we continue down through the article. Is there any additional evidence that supports that particular claim? There is. I'm not going to go through the time over that. But then are there any other claims that are going to be made? So if I skip on to the second page here, one of the things that we can see is that the Thermosphere Climate Index is on the verge of setting a space-age record. So not only are we seeing a cooling trend, which would be one, and we're kind of splitting hairs here a little bit, and your students will do that as well. But what's another claim is going to be, I'm going to say space age minimum, or record minimum. Okay, so not only is it trending downward generally, it's also going to be a new record low. And then what's the evidence from that? Well, we've been measuring the data, we've been measuring the actual thermosphere luminosity of those particles using the SABRE instrument for quite a while. And now how is it that we are looking at that, but not only from the thermosphere, from the data in the satellite, but also from other recording devices. So for here, evidence is coming from actual thermosphere climate index. So I'm just going to write TCI, short and sweet, keeps life simple. And then the citation here is going to be coming again from, we could use one of the references listed here. Milnazak is going to be the #1 individual who's quoted here. So I'll again say that Martin M. from NASA. Now, could we also use citations directly from the instrument itself? Potentially. Again, this is going to be up to you how you're going to want to show your students to kind of break this article down. This is just another way for them to digest articles. If we're looking at obtaining and communicating information, it's very difficult for a middle school student to read an article that, while all the material is something that they should be able to understand, they might not be able to put it into words quite the same way. They may just kind of copy and paste verbally what they've read. Oh, this is what it means. Okay, well, what's the impact of that? Well, it doesn't say it in the article. I know. I want you to think, like, for yourself. So that's going to kind of bring us down to the rest of this outlining tool. What's the methodology? So now we're going to be looking at this from the scientific method. What's the observation? What's the question hypothesis? What's the testing that's been done? What's the analysis, and what's the conclusion? Well, we already kind of know the conclusion is going to be the answer that was raised at the beginning of the article, which is going to be less sunspots is equal to a lower thermosphere temperature. Okay, so I can put that down as my conclusion. Conclusion is going to be, I'm just going to put answer above. What about the observation? Well, we're seeing a downward trend, and then we're going to come up with our question. So downward trend. What's going to be our question or our hypothesis based on that observation? Is that related to solar sunspots or solar flare activity? So question. I'm just going to write sunspots. Question. How did they test this? Well, they're using the SABRE instrument on the timed satellite. And then when we look at the analysis, well, thankfully we've got this lovely graph, and we do see a downward trend. So I'm just going to write graph for analysis, and the answer was stated above. We see a downward trend. Then E is kind of where we would come back to this. Here is going to be the R on the scalar method. It's E on my outline for this is, where do you agree or disagree with the author's position? Well, based on the data that's presented, would you agree or disagree? You know, again, that's going to be personal to the student. But based on the data, yes, there is a downward trend. Thankfully, this article is not attempting to address any of the political ramifications here, is not trying to address human impact, is not addressing anything else beyond that. It's just looking at these particular data points. Based on those data points and the claim that the article is making, do you agree? Do you not agree? That's it. That's all you're going to be doing here. Agree or disagree. So I'm just going to put a check mark, or I don't know, like a frowny face or something. Check mark or frowny face. Up to you, however you want to do that. All right. Did the author use any logical fallacies? Now, one of the things that I will spend a day on in my class, particularly for students who are the high flyers, and I'm going to make sure that they're kind of dispersed amongst the class, is I'm going to have them work through a logical fallacies website. Any logical fallacies that you're going to present to your students for them to learn, I highly recommend that you read up on them yourself first. I really like using logicallyfallacious.com. You will have a link to that in the presentation that I had at the very beginning of all of these classes. Logically fallacious is rather humorous. However, a few of the examples that he uses are more like high school level appropriate. And of course, you just need to read over whatever you want your students to look at. Logical fallacies. So one of the potential logical fallacies here is that there is an appeal to common belief. One of the appeals to common belief is that if NASA says it, then it must be beneficial. Other potential logical fallacies, not necessarily in this article, would be appeal to anonymous authority. Well, science says, stop. Science isn't a being. It can't say anything. It's a tool. Now, you might say, well, the statistics show. What statistics? Be specific. You know, we want our students to be specific. We should be specific too. And that's really the purpose of this. We're going to be breaking things down, looking at them for what they are. And since science is trying to help us understand the world around us, regardless of what grade level or ability level our students are at, they can ask appropriate questions that are going to be based on this. They want to know why. Let's show them how to find out. And then finally, what other questions might you have after reading the article? This is a great place for you as the instructor to kind of toss something in and say, you know, I've got some questions based on our material that we're learning in class. So, okay, when I am looking at ecosystems in the Serengeti, and I'm looking at, all right, so we've got this biome and we've got this biome, how are the temperature variations in the thermosphere going to affect, you know, sub-Saharan elephant herds or something? How would that come up with? How would you answer that question? Now, how do you want your students to answer the question? And that's where they're going to be bringing in stuff that they've already read, maybe a video that you've shown or an activity you've done in class, and now you can kind of put all of these pieces together, and that final part will lead us into our next video.